you want to be nice, you don't have to. You will use something 0 to whatever, because that's easier, but you don't have to. Maybe we should go through an example without starting at 0. And any function that is linear, quadratic, or cubic. Any function. Let me plug in my laptop. Okay, ready. Any function you want to work on or with. And yes, areas could be negative, in case you're asking. So we can have a function that looks like this. This is a positive area, this is a negative area. In absolute value, this is much smaller than this. So the result will be negative. So that is possible.
What about if there's like a vertical asymptote or horizontal asymptote?
Excellent question. F has to be a continuous function. Otherwise, you have to wait till Calc 2. Very good question, Mark. Thank you. Okay, can anyone make up a function? Linear, quadratic, or cubic? If not, I will. Okay, so let's say 2x cubed plus 4x minus 3. Any interval?
Maybe like 1 to 7?
1 to 7 is perfect. Very good. So we are asked to find the area under f of x between 1 and 7. Okay? And remember the 3 preps. First prep is delta x. 7 minus 1 divided by n. So that is 6 over n. And this is, remember, is the width or the base of each rectangle. Stop me if you have questions anytime, please. Number 2 is xi. We know now, and if you want me to show again how we get xi, please. Do I need to show again how we get xi?
Yeah, can you do that, please?
Of course. The interval is between 1 and 7. And it's divided up in n subintervals. All of them have this width. So this is 6 over n, this is 6 over n, and so on and so forth. This is the first subinterval. It doesn't matter, because we have n and n goes to infinity, it doesn't matter if you use the leftmost point, the rightmost point, or the midpoint. Nobody cares anymore, because there are n subintervals and n will go to infinity. So how do I determine x1? Well, x1 is 1 plus 6 over n. In other words, 1 plus delta x. x2 is right here. What does x2 equal to? Obviously 1, but twice delta x. 1 delta x plus another delta x. And I continue like this, but I really need xi. So xi is right here. So how will I write xi? Of course 1, so notice 1, 1 in front, 2, 2 in front, 3, 3 in front. So this will be 1 plus I delta x, or 1 plus 6i over n. It's going to be a lot of calculation. So because we chose 1, you know what, I'm not going to change anything. But before you ask, No, you're not going to get something like this on a test because it's too much work and it will take a long time. So this is for us, for practice, so we understand what we are doing. Okay. Do we understand how we got xi? Any questions about xi? Okay, in step number 3, the last prep, I have to find f of xi, which is f of 1 plus 6i over n. But now the function is a mess, because I have power 3. It will take me a while to take this to the third power. But that's okay. We're going to do this only once with such, starting at 1, but you need to see 1 at least. Okay, so 2. First I'm going to square them and then multiply again by another one. First term squared plus 2 times the first times the second. Sorry. Plus 36i squared over n squared. Here I can distribute 4 plus 24i over n and minus 3. Okay, so now I have 2 in front. I have to distribute 1 to these 3 terms and 6i over n to these 3 terms. And then simplify as much as possible. 1 plus 12i over n plus 36i squared over n squared plus 6i over n plus 72i over n squared plus 216, I think, I cubed. Hold on. This is okay. This is okay. This is not okay. Okay, so I cubed over n cubed. I think I'm okay. And then plus 1 and plus 24i over n. Okay. 2. In descending order, 216i cubed over n cubed. Now these 2 terms, plus 108i squared over n squared plus, now these 2 terms, 18i over n, and then plus 1, and then outside, plus 1 plus 24i over n. So all this got complicated because at least one example we wanted it to be starting at another number but 0. If there is nothing else but 0 here, of course this will be a much easier situation. It will be just 6i over n. I will not have a binomial to square or cube, but that's okay. So now I still continue simplifying it. No, this is 3. Okay. And I have from here. Okay. So 2 times this. I have 432i cubed over n cubed. And then plus 216i squared over n squared. Plus 36i over n. Plus 2 plus 1 plus 24i over n. Finally, 432i cubed over n cubed plus 216i squared over n squared. Now these 2 plus 60, 60i over n. It was 24 and 36. I over n plus 3. Okay, finally we have all 3 preps. And now I can write the area equals the limit as n approaches infinity from the sum from I equals 1 through n, and I need delta x. 3 pages ago, delta x is 6 over n. and multiply by f of xi. 432i cubed over n cubed plus 216i squared over n squared plus 60i over n and plus 3. Okay, now one property that we talked about, the factor that does not depend, it's a factor, this is very important. The factor that does not depend on I goes in front, and then, because I already wrote 3 pages on one problem, I am going to say that the sum of this plus the sum of this plus the sum of this plus the sum of this already. Okay, so this is limit as n approaches infinity 6 over n bracket. When I apply, just to cut back on writing a little bit, when I apply the sum to this piece goes in front as a factor in front of the summation notation. 432 over n cubed, the sum of I cubed. Plus, I apply the sum to this term, and 216 over n squared goes outside, the sum of I squared. Of course, from I equals 1 to n, I equals 1 through n. Plus, the sum of this, 60 over n, the sum of I, from I equals 1 through n. And plus, 3, the sum of 1 from I equals 1 through n. And as you see, we are using all, I put that in the trash already, we are using now, in the recycle bin, we are using now all identities. This will be replaced by n plus 1 divided by 2, everything squared. This is the ugly one, will be replaced by n plus 1, 2n plus 1 over 6. This will be replaced by n, and this will be replaced by n plus 1 divided by 2. Okay, and then I apply the limit and we're done. So limit as n approaches infinity from 6 over n. 432 over n cubed. I will square this. I don't want to put it here and then square it. So it's going to be n squared plus 2n plus 1 divided by 4. So I squared n. I squared n plus 1 squared right here, and I squared 2 over 4 plus 216 over n squared times. I'm going to multiply, and I think now I'm on 4. I'm going to multiply, I'm going to leave n alone, but I'm going to multiply these two. So that is 2n squared plus 3n plus 1 divided by 6. Now I'm here with plus 60 over n. Here I'm not going to do anything. n plus 1 over 2, and plus 3n. So what happened just now, I replaced all the sigma notations with what the identities that we looked at last time. And now I'm trying to simplify everything in brackets and then apply the limit. Okay, so let's see what we can do here. 216, that was 36. Yes, so I can simplify. I can simplify by 2, yes. Can I simplify 432 by 4? That's what I need. So divided by 2, lazy people like me use a calculator. Oh my goodness. Okay, so I can also divide by 2 again. Oh yeah, awesome. So I can get rid of these numbers, and I got 108. 432 divided by 4, yes. I can simplify this and I get the 36. And I can simplify this and I get the 30. Okay, awesome. n still stays. This I should not simplify, but I simplify 2 from here with 2 from here, 1 from here with 1 from here. So now I have limit as n approaches infinity. 6 over n stays in front. The least common denominator is n, and I will distribute 108 here, 108 n squared plus 216n plus 108, and I'll distribute 36 in here, and you know I'm going to run out of room, so I'll better just write it here. 36 times 2, 72n squared plus, again 36 times 3, 108, yes, and plus 36, and then plus 30n squared plus 30n, and this one needs an n, plus 3n squared. So this is, all this is up here. Okay, now combining like terms. N times n, the denominator is 6, is n squared, the numerator gets a 6, and now let's see what we get here. Okay, so I have the 108, I have the 72, I have 33, 213, okay, now 216, plus, I'm checking the 108, because I have here 36 times 2 and then 108, 36 times 3, yes, and plus 36, okay. So 216 plus 108 plus 30, so 354n plus just 108 and 36. I think that's it. So this is 144. However, these terms will really not count, because when I differentiate using L'Hopital's rule, I will still get 6 times 2, 13. And that will be the answer. So that's it. I cut it short. I did not use L'Hopital's rule twice because that's exactly what we're going to get. So 6 times 2, 13 divided by 1. And these terms will disappear after we differentiate twice. This was a long process. Yes, I write big, but still a long process.